Interference and superposition. So now when waves travel through a medium, and remember a medium is air, glass, water, diamonds, anything, a wave will travel through it. They'll cross paths with other waves. And so interference happens when two waves cross through at the same time. And we call this the principle of superposition. It predicts the new shape and the amplitude. So, okay, there's 4 diagrams in this space. I'm going to use 2 different colored markers. I'm going to use pink and purple to show you 2 different waves. What happens is we go like this. Wave A, I'll make pink. You make whatever color you want. And wave B. Okay, so this end is like Princess holding on to the slinky, and this end is me sending off the wave. Wave A is moving in this direction, and wave B is moving in this direction. Okay, at some velocity. What happens is, as they meet, this wave comes up with its amplitude over top of wave A. Okay, so we call this here the region of overlap. I'm not going to get as technical as what's in the teacher's notes. Feel free to go back. I'm going to simplify it a little bit because it gets super incredibly complicated. Remembering that this is wave A and that this is wave B. Okay, so now what we see is wave A is going this way, wave B is coming this way, and they are starting to overlap each other. As it moves through, we see wave A go this way, wave B is traveling on top like this. This is wave A. And this is wave B. Okay. Wave A is still going this way. And wave B is still traveling that way. And you can see that this region of overlap is extended now. And then in the last one, wave A and wave B. And the region of overlap has narrowed back down. Now, what you notice is, in theory, if I was the Bob Ross of all physics teachers, is that the wave amplitude of wave A never changed. And the wave amplitude, right? Amplitude is from the point of equilibrium to the crest or the trough. the amplitude never changed. This here is the same as this. This is the same as this. Okay? Again, wave A is moving on by just like wave B is. Okay? So the amplitude for each individual wave did not change. But yet, what do we see here? What do we see here? Do we see a wave the same height as wave A? Because wave A is bigger than wave B. Or do we see a wave equivalent to the size of wave A and wave B? What do we see? Do we see the equivalent of wave A, or do we see the equivalent of wave A and wave B? So the amplitude of the crests are positive and the amplitude of the troughs are negative. That's a standard way of indicating what we're looking at. When two waves overlap, the amplitude of the resultant wave is greater than the amplitude of the two individual waves, and we call it constructive interference. Okay? This is key wording that's very important. Constructive interference. Okay? That's this here. That's this big blue wave. Right? Here's wave A, here's wave B, but what we see is the constructive interference and then essentially new wave is much greater. Okay? Daniel and Cedric, pay attention. When crests from two waves or troughs from two waves overlap, it's said to be in phase. So crest and crest or trough and trough, it doesn't matter. So we have this like this meeting another wave like this, or a wave like this meeting another wave like this. Okay, doesn't matter. Crest to crest or trough to trough. Together, both a crest, together, both a trough, in phase. Okay? When two waves overlap and the amplitude of the resultant wave is less than the amplitude of the individual waves, this is known as destructive interference. And we're going to put a series of 2, 4, 6, 8, 10 pictures in here. So here's a wave like this. Actually, we're going to divide this in half. Okay, so this is what we just looked at. This wave is traveling in this direction. This wave is traveling in that direction. This one has an amplitude of 2. This one has an amplitude of 3. They get closer. 2 is still going this way. 3 is still going this way. They meet, and we don't see the distinction between 3 and 2. But what we see is an increase in amplitude, and it's the sum of the two wave amplitudes, crest to crest meeting. Here's wave 3, still moving that way. Here's wave 2, still moving this way. This is in phase, and this is constructive interference. Okay, that's what this is, constructive interference. Wave A is a crest, wave B is a crest. They meet in phase. Here's the second scenario. Here's wave 2. Here's wave 3. Or wave A and wave B. Amplitude of 2, amplitude of 3. This one's moving in that direction. 3 is moving to the left. Okay? They're going to get close to each other. This wave is moving this way, and this wave is moving that way. What happens is we won't see this, so I'm just going to put it like this. If I have 2 moving this way and 3 moving this way, what do you think the amplitude of this wave is? -1. Okay? The amplitude is -1. It's still the sum of the 2 waves, but the trough of wave B was greater than the crest of wave A. 3 is greater than 2. And so we have this negative wave, for lack of a better word. The negative tells us that it's a trough. And then what we see is this wave 2, or wave A, is still moving through. It has its amplitude of 2. And this is wave B. It has its trough of 3. Okay? We could put a negative sign in here to help us indicate that it's a negative, or that it's a trough, because that's what a negative will do. These are what we call out of phase, and it's destructive interference. If this was a sound wave in this half here, would this sound get louder or softer? Louder. If this was a sound wave, would the sound get louder or softer? Hence the concept being used for noise-canceling headphones. How many people here have noise-canceling headphones where it shuts out the background? This is the concept. This destructive interference is what they're using. Okay? What does this look like? Well, here's my source of sound right here, or my source of the wave right here. Here's another source. Source 1, source 2. So I'm going to alternate these with dashed lines and solid lines. A dashed line, we could say, is a trough, and a solid line, we could say, is a crest. I made these really far apart. You're going to want to make them closer. Otherwise, you're just doing a lot of drawing. It doesn't change anything. You're just going to do a lot of drawing. Just going to make these closer, just to make life easier. Okay, so the first part of my wave that goes out is up and then down. So crest, trough, crest, trough. I'm just going to go to the line of equilibrium. Crest, trough, crest. You get the idea, right? This guy here has crest and then a trough. I'm going to do it in red. A crest and then a trough and then a crest and then a trough. Okay, you get the idea. What we see is when we have a crest and a trough, or crest and a trough, crest and a trough, crest and a trough, crest and a trough. Here's a, it would have worked out. But anyways, we see this pattern of constructive. Sorry, wrong. A crest and a trough will give you what kind of pattern? A crest and a trough will give you what kind of pattern? Destructive. Okay? Here, where we see a crest and a crest, crest and a crest, crest and a crest, or trough and a trough, we see constructive. Okay? So where you see a crest, destructive. Where you see a crest and a trough overlapping, you have destructive interference. Where you have a crest and a crest, or a trough and a trough, here's a trough and a trough, here's a trough and a trough, you're going to see constructive interference. The sound or the wave, the amplitude is going to get larger. It could be a light wave, it's going to get brighter. Sound wave, it's going to get louder. Okay? Questions? Comments? Concerns?